Hi guys, this will be part 2 of my tutorial of Kicad. Well, the first part was a bit longer. I tried to take things slower for the beginners to just try to understand what's happening on the screen. So I believe this is where we left off at the first part, and we already made some orders through Farnell distributor website. And in this part we will try to find footprints for these parts, maybe possibly make a PCB. Before I started this video, I already prepared an order from Farnell, and in that order I ordered also a casing for the project. So this casing for the project, I've chosen one of thousands that's available on their site, and I've chosen this enclosure for the project because of the sizes of components that will fit inside. The biggest component that we have here is capacitor, this one, and I've downloaded its data sheet right here. So we have 400 volt rated capacitor, 22 microfarads, so size code is J21, and if we go over there to J21 we can see the L, the height of capacitor, is height is 60, J21 is 21.5 millimeters. So 22 millimeters. So we needed a case that could fit in height this capacitor, the height of board and everything inside, and even some cables and pins and stuff. So I've chosen this one, and also I downloaded its data sheet here, so we can see when we start making our PCB, we can see the sizes. You can see the sizes of maximum size of our PCB fitted inside, and and everything nicely, neatly done. So let's go back to Kicad. This is where we left off last time. So in this tutorial, first I will try to choose PCB footprints for the components. If you're a beginner, if you do not know what the footprint is, and this is very basic concept. So each electronic component has, let's say, like a shadow on a PCB, together with its contacts, which will be soldered to a printed circuit board. So virtually, it's a footprint is a way for your CAD program to know how to connect your real world component to your PCB. So the first thing we have here, and easiest, is a resistor, and I will show you how to choose your package or footprint for your for resistors. So if we go back to Farnell site, we can see that we've chosen two resistors. I've chosen big beefy resistors because it will be much easier for soldering. If you're a beginner and following this tutorial, or just doing something similar, this will be much easier than soldering very small components. So I've chosen this 2512 size of package for resistors. Well, these numbers for resistors is a bit confusing, but if you go to Wikipedia and check what the resistor case style, what the numbers mean, the numbers are basically the size of a component, and this for resistor is very easy. A lot of PCB CAD programs have already a list of standard size resistors, so this will be pretty easy. But also this could get confusing, especially for a beginner. So every time I make my own PCB, each time I check the footprints, and I rarely use a footprint that
I didn't check, I just placed it on board or whatever. So for every footprint I make, I go on, I download data sheets from the maker, and I try to make my own footprint if there is if there's none in the program that I use. Even if I use programs like Eagle or some other programs that have thousands and thousands of footprints inside, I never place a footprint without checking it. Okay, so we know that that footprint we need here, that package is 2512. So you can choose your footprints for your components, your packages two ways. But before we go into that, I will just add some things to this circuit that we are missing. So I put this VCC and ground because you'll be putting those in virtually any circuit you make. But we will need two connectors to connect something to these wires. So I will use this package this component that I already made. This will be our connector. In Kicad, when you need to copy something, you just go over with your cursor and press C, letter C. So we'll make a copy of it, and then I'll make another copy. Alright. So also, if you need to move components, you just grab them like this and move them. So each time you do a square, you do this rectangle around your components, they will stay attached to your cursor, so you can move them anywhere. Let's say right here. Okay, I will not connect directly a wire to VCC and to ground, because I just want to show how would you do it if this was a bit more complicated schematic. So in that case, if you have like hundreds and 100 different wires and different nets and a lot of components, if you put everything and connect each and every pin by wire, it can get very confusing extremely fast, and you will get a spaghetti schematic, which will be very hard to read, especially after a while you've been you drawn it and you didn't look at it for a few months. So what will I do here? I will connect two like virtual wires to these two connectors, and then tell Kicad that these two wires should be connected to VCC and to your ground. So we have, for that, first I will draw two wires, pressing W and double clicking where the wire ends, and this one hangs in the air, it doesn't matter. And I will do the same with another one, and I will press escape to go back to my normal cursor mode. So I will be using this place net name. So I will be placing names on my wires, on my nets, and by these names Kicad will know how to connect. So you can press this icon, or you can press letter L for a label. So I will put the name here, let's say input. Yeah, I will name it input power, and I will press L again, and I will put input ground. Well, names are irrelevant here. If you give a name to a net, Kicad will know that these two nets are connected on a PCB. But I suggest naming your nets somehow logical, so you will know when you have like hundreds of nets, you will know by name which one is which. So the easiest way how to connect these two now is just to copy your net name with the letter C and place it on this piece of wire. I will copy another one. And that's it. So these two lines, this one and this one, are virtually connected, and when you draw your PCB, those will get connected automatically by Kicad. One thing that we missed that I promised we will be choosing later is a bypass switch. So we need to change this circuit, so in a way that we will add a switch, and when you choose one side of a switch, circuit will look like this. This 300 ohm resistor will be used. But if you toggle the switch on another side, if you toggle your switch, then we'll bypass this resistor and basically cut it off. So I will press A to add components. I will go to I believe devices, yeah, device, and there is, yeah, this one. So this is single pole double throw switch, or single pole single throw, never mind. This is the switch that we are using. I'll just press it, put it into a circuit. Okay. So I need to rearrange my circuit a little bit here. So I will use one side of a switch directly, and the other side of a switch should go through a resistor. So I'll be moving these parts of my circuit, and I will be inserting this switch. So in case you need to do that, you need to delete some lines. I will press escape to get a normal cursor. I will just go over my line and press delete. So you can see Kicad deletes it. I will delete this line and this line. I will move this over here. I will move also my diode. I will delete this line. I will move over. This resistor over here, and I will try to fit a switch somehow. Yeah, so I will move resistor back here. I'm doing everything with letter M. Okay, so and then I will have my diode moved here. I will move my VCC over here. In fact, I will move it over here, so I will have place to put this label name. Okay, so let's start connecting again. I will connect this one to here, and this one will be connected here. This one will be connected here to this one and to this one. I just click on each and every connection just to make sure that the Kicad has connected them, and I will connect these two and these two. I will press escape and then move my label name over here. So I don't know, did you notice? I press Ctrl Z to undo. If the label is not connected, you will get this small square on one side of your label. So when you just move it, your cursor will jump to that small square, and when you place it on the line, it disappears. Okay. So more or less we have our circuit over here. So I will grab again everything and move it a bit like closer to center. Okay, this is it. Now I will name all of my components, and this will be very easy. Actually, any program that I worked with before has this feature of naming all components in your schematic. And here in Kicad it's here, annotate schematic component. You can do one by one. Let's say this diode, you can go with your cursor here, press E to edit it here directly, like D1, or you can edit complete component and change the same name over here, reference D1. In this case, I will, in some places, and I usually do things when I need my components named logically. Let's say I have a switching regulator on one side of a board or something else, so I need like I give names to components that I will, when I check my PCB after a year, there'll be a like logical naming of components. Let's say I will number the resistors in one part of a circuit to 1, 1, 1, 2, 1, 3, and I don't know, on another side of a board these resistors will be named 22, 23, 24. So I will, by number somehow I will know it. So let's press this here. I will keep everything as default. So if you have time at home, you can just play with these, but you need to know that you cannot undo. Once you annotate your schematic, you cannot go back. So I will annotate it, and this is why Kicad warns me that this cannot be undone. Okay, so you can see Kicad named all of our components right here, and then I will save my schematic by pressing on this icon or just pressing Ctrl S on my keyboard. Okay, this is it. So let's start choosing our footprints. As I already told you, I will start with resistors. So I will go over here, and I pressed letter E for edit, so I will just press E and then edit component R. I will go to footprint, and here assign footprint. You have a lot of libraries here, so logically I will go to resistors SMD, and there is a 2512 resistor here. So you have two different footprints for this. This is a resistor. This is a resistor package 2512. Both are the same, but this bigger one is used for hand soldering. Sometimes there are a lot of sizes of same components. If you check, there are different sizes in the pads, so the exposed copper in your PCB can have different sizes depending on your use or the size of your board. Sometimes you just need your bare minimum copper if you don't have size on your board, just so you can squeeze as much as you can. Here I believe we have a lot of space, and I'm tempted to use this hand soldering footprint. But before I use it, I'd like to check the sizes. So I'd like to check, is this correct size to this 2512 component. So if you don't have any component catalogs and sizes, Google is your friend. So you can just check 2512 resistor footprint, and you can check even images. So there should be a clear image of our footprint somewhere. So let's try to find one that looks. Actually, let's go back, and I've seen a V-shape components as a first result in a Google search. My internet is a bit slower over here. I use USB stick, so yeah. Let's try to find sizes. Okay. Yeah. So this is case type 2512. Let me just check. Yeah, let's try to find the data sheet for it. Okay, so case size is this 2512. This is our resistors. So I'm interested in this minimal. I will zoom into this. So minimal G distance between the exposed copper pads, and this is 5.18. Let me just check. This is millimeters and inches. 5.18. So how to check this in Kicad? If you check over here on the bottom right part of your library browser, there is a cursor there is a coordinates of your cursor, and you can see these coordinates are absolute, and this is dx and d epsilon, but now they're all the same because this is the center of your coordinate system. But if you go over to this side and just press your spacebar like this, then your dx and dy is reset. So when you move your cursor away, and you will have a distance for your original point where you press your spacebar. I will go over here, and it's 5.2 millimeters. This is good. So Vishay says it's 5.18. It's good enough. X, the width of exposed copper pads, is 3.19. So I will go over here, press space, and I'll go on top here. It's 3.2. It's dead on. Well, I believe the only thing that this will not be good is just this length. I will measure complete length, and it says 10.6 millimeters, and let's go back to Vishay. It says 7.2. So this will be 3 millimeters, almost 3 millimeters longer than it is. But this will be much easier for soldering, I believe. This part is basically the same. Look, if you check the distance, let me check, it should be the same. Yeah, it's 5.2 millimeters by 3.2 millimeters, and the length is 7.2. So this, why is this not working? So this is exact as per specification. Well, I think I will go with this footprint when I think about it, because this will be used in marine environment, and I just want to have exposed tin or copper, expose my soldering as less as I can. And these components are so big, it'll be much easier to solve. It will be easy to solve. So I will choose this component by double clicking it. And I will press OK. And if you go again to your component to edit it, you can see that footprint is now already in. So we will do the same with this resistor. We'll do the same with this resistor. So Kicad is already offering you last component that you've chosen. I will choose this one. I'll press OK. So now we have footprints for these two resistors. Let's check footprint for our diode here. So we're missing a footprint. Let's go back to our Farnell. Choose a diode. It's standard power diode right here. Our page is goofed up. My internet is slow today. I will open it in a new tab. So sorry. We will try to find exact footprint for this diode. If no, I will draw it. I will make a new one. Okay, page is not so, but I will go just to this data sheet, and let's check. Do they have? Yeah. Okay. So this is layout for this diode, DO214. Let's go to Kicad, click on assign footprints, and is there yeah, there's a diode SMD. So let's check, sorry, let's go back here. Let's check, do we have this SMA package with this size? So I will try to find this SMA in the library browser. So this is supposed to be that SMA diode. I'm not sure, I'm not convinced. When I look at it now, I don't think it is. But let's check the size. Is it correct? So I will go back here. Distance between the pads should be 1.88 millimeters maximum. So let's go to our library browser. Let's go with our, I'll reduce the grid. This is small enough. Let's reset your cursor here. This distance is 1.5 millimeters. Let's zoom it here. It says 1.88, and the total distance is 5.28. So from here to here there should be 1.88. It's 6.5. It's millimeter longer. And let's check one more thing. I have here to here is 1.88 millimeters, and it says 1.60. Well, this pad actually would fit. This pad would fit, but I will make my own components just to show you how quick it is. So also, if you see this component, there's this violet dot here actually is I think it's a glue. So on your pick and place machine, if you're making this one, your manufacturer should put a dab of glue before sticking this to your PCB. Okay, let's not waste any time. Let's make our new component. So I will select active library, and I will select diodes SMD, and I will make a new component. The name of component will be this one. Copy. Copy. This is it. The name of 214AC. Okay. So I named the component. I will move this over here in order to get space for our component. And for the reference, I will press E. I'll change reference to D. Letter D for diode. Well, refreshment is one of the sometimes your screens just goofs up while you're using Kicad, and it doesn't bother me a lot. I just zoom in, zoom out, and it clears up. Okay, we need to use a new pad. You go over here and add pads. I will click anywhere for the first time, and then I will go in, and then I will press E for edit. So okay, we know we'll have two pads, and we know that those will be SMD and rectangular. So let's go back over here and check the sizes of this pad. So pad will be 1.52 by 1.68. I will make those pads a bit longer, so it's easier to solder. So I will put this pad to be square, 1.7 by 1.7 millimeters. So I will put 1.7 by 1.7, and then I need to have coordinates for the pad. So if you look over here, this is the center of your component, and everything left of this line is minus X. So position X will be minus, as you can see here, and everything below this line, this blue line over here, I don't know, can you see it on the screencast? It'll be plus 1, plus Y axis. Okay, I made my components 1.7, 1.7, so I need to add half of this 1.9, 1.88, so this is 0.94, let's say. Half of this from the center of component to this pad is 0.94, and then half of this 1.68. I made it 1.7, so I need to add 0.85 to 0.94. So I can use my calculator. Oops. I can use my calculator over here. So we have 1.88 divided by 2, 0.94, and 0.94, so plus, I will over parentheses, and there will be 1.7 divided by 2, it's 1.8. So distance from from the center of component to center of my part should be 1.8. So let's put that in. So position X is minus 1.8 and position Y is 0 directly on the line. If you click OK, now you can see our new pad. I will just make a new pad by clicking here, and Kicad will make the same pad as the last you already done. So this is pad number 2, and let's check its properties. So position I know this is 1.8, and everything else the same. Now we can check distance. I will just use a smaller grid, 0.05, so it will measure more precisely. So let's go over from this part. So you can also press spacebar from this here to here. We have 1.9 millimeters, and if you check here, it should be okay. So we compare this. So it's 1.9 exactly as we need, and we can check this one is should be 1.7, 1.68. So one from here to here, there's from here to here 1.7. Okay, this is good, but there is a problem. You need to name your pads exactly as in your schematic. So your component in your schematic should have the same pins as names on the pads in your footprint. And how to make sure it's really like that? So yeah, the thing you can do in Kicad, you can edit a component and check the chip name, and then go into edit library, load library that you need. This is device library, and then you can load the chip. So chip name is D. Yeah, okay. And then you can check the name of your pins. So cathode is pin number 1 and anode is pin number 2. And we will do the same in our footprint editor. So we know cathode is number 1. You can check it again. Cathode is number 1, and that's it. So let me make a small, I will just reduce grid to 0.2, and I will make small, actually, I will do it like this. Let me just check the width of our component. So the width is 2.79 millimeters. So 2.79 millimeters, and the length is 4.5. So again, we can help someone, whoever is putting this board together, and draw a better looking component on it, or you can just draw a square. In this case, I'll just draw a square and mark where the cathode is with a band, but I will make this square as wide as the component, so 2.8 millimeters wide. 2.8 millimeters wide, and as long as the pads. So let's go back in a footprint editor. So 1.4 millimeters wide. You can check again. I'm doing this. I'll do this now just by arrow keys. So you can move your cursor by arrow keys until I get to 1.4, exactly here. So this will be our diode, and if I wanted to draw complete diode as it is right now, I would put, in just a second, if I wanted to complete this diode, I would put 4.5, I will put 2.25 millimeters in one side, so like this. Yeah, somewhere here. Okay, let's try to do like that. It's here. So I just press enter to complete the line, and double click to I just press enter to put another dot on the line, and I double click the line to stop drawing. So this is 1.4 also. I press enter, I will double click it, and I will go over there, here, so it's 2.2, and here, and I will double click. Okay, so we need to mark this as a cathode, and I can do a little bend like this. It'll be visible here, here, and here. Okay, I can even reduce the size of a grid and put one line in the middle, and this will virtually be filled up. Okay, and I will also mark a cathode over here. I usually do that so after soldering, when I place my components, this part will be invisible. You cannot see this part of your component. Okay. So basically this is it. This diode is completed. I will move this over here, and I will edit this name and make it invisible. That's it. So now you can save your part. We already given the name. I will press OK. I will exit from here. I will go back to my schematic, press E. I will assign footprint, and there should be in diodes list, there should be our diode. Yeah, here it is. I will double click on it, so it's now here in field value, and I will click OK. So we have this footprint. As I plan to mount this switch on a chassis, I will just edit it here, and I will just put any three-way connectors, standard. I will put pin header, 3-wire pin header. I think this is good enough. Maybe let's say we have anything spaced wider. No, this is SMD. This SMD is good enough also, but I just, for the time being, let's put header. Do we have any headers maybe here? Nope. Nope. Okay, I will use this one. Okay, and I will edit this field footprint. I will make this invisible and save everything. Okay, so we have two components more to choose for the footprint. This is capacitor, and I've checked this before and I couldn't find the footprint for this capacitor. Let's try to do it. I have capacitors SMD, and I have these electrolytic capacitors, but I cannot find the size. I have data sheet. Data sheet is over here. So in data sheet I already marked it's J21. Oops, sorry. It's this is J21 size. Let's check this again. Just in, we have 400. It's 2G220M. 2G220M. And let's go back here. 2G220. no, 2W220M. 2W220M. It's this one. Its size is K21. Let's check this again. K21. Yeah. Okay. So size is K21. So this means that this case here, plastic case for SMD capacitor, will be B times 8, so it's 19 millimeters wide, and the case capacitor itself is D, it's 18 millimeters. Sorry, here it is. Okay, if I try to assign footprint, we'll try to find this CLEC capacitor, but there is no 17 times 17. Let me check again. Yeah, 19 by 19. There's no such capacitor. The thing is, with this data sheet, there's no, if you browse through it, there is no recommended footprint. So let's try to find footprint on Google. I will copy name. I will copy code for size code for capacitor. I will go over here. We don't need this size reference anymore from Vishay. I will close this one also, and I will Panasonic capacitor size code K21. Okay. Let's try to open this one. No, this is the same data sheet. Yeah, there's a Panasonic technical guide. Let's try to do that. Okay. So I will try to find K21. K21. Let's zoom in. K21. Let's try to find the size. K21. Nope. So SMDs are here. Is there a recommended landing pattern? Ah, yeah, here it is. Actually, yes, it is. So U is, this is K21. So U is this, the width. U is the width of a landing pad. U. And T is the length. So T is the length, 6.5 by 1.2. So this is our size here. Yeah, here it is. So let's put that in a footprint. Okay, I will close this. I will cancel also this. I will go into my footprint editor, and I will select active library as capacitors. Okay, and I will make a new footprint. So let's check. This will be 19 by 19. So what's the name of other? Just a second. Let's check name. Let's check the name of other. Let's check the name of other capacitors over here, just in order to have the same name. So capacitors SMD, and I will like open one, select by browser. So CLEC. Okay. We will make a new one. It's C. connect, so 19 by 19, and we'll call this K21 just to make sure. Okay, this is our new footprint. So let's go and move this over here or here, and I will edit this reference to DC, and I will place a pad over here, and I will edit it immediately. So this will be SMD rectangular, and let's go back here. Size is T6.5, so size X is 6.5, and 1.5 is size in Y direction, that's U. 1.2, but this is not recommended landing pattern. Just a second, this is just the size of a tab. Let me go back over here. Here it is. Okay, so K size. Okay, it's A, B, and C. So standard products. This is our standard product. It's not vibration proof with this, with this bigger connector. So let's go. This is lens space. We need to find C. C is 2.5 millimeters by B. B is 7.5. 2.5 by 7.5. So this is 7.5 by 2.5. And let's go back here. Position X is A divided by 2 is 3 millimeters plus half of B. So 3 plus 3.75, 6.75. So this is minus 6.75, and we'll position this straight on a line. Let's check this again. 7.5 divided by 2 is 3.75, and A divided by 2 is 3. 3 plus 3.75 is 6.75, and we are looking good here. So I will just place another pad over here. I will edit it, so I know that position here is 6.75. This is 0.75 by 2.5, and that's it. The next thing I need to do, I need to draw a size of my capacitor. This size. It's 18 millimeters. So let's go back over here. It's 18 millimeters. I will select my grid to be 1 millimeter long. I've chosen this circle here from my toolbar. I will press in the center, and I will use my keyboard to go and to let me just check again. It's no, the size is 18 millimeters, so that means radius is 9 millimeters. Okay, oops. Radius is 9 millimeters, so I just check my coordinates, 8, 9. This is it. Okay, then I will go again to part library editor, to my schematic, and check. It's CP is the chip name, and in part library I will load component named CP polarized capacitor, and I will check the number of tabs. So cathode is number 2. So cathode is number 2, and you need to mark the cathode. In just a second, I'll reduce the size of grid, and cathode is usually marked with, I will put a smaller grid, yeah, like this. Cathode on the SMD polarized capacitor is usually marked like this. Yeah, here it is. this is good enough for the time being. The next thing, sorry, I need to draw a case. It's so B times A, it's 19 millimeters and 19 millimeters, and it's tapered off on one side. So usually I have one SMD capacitor here in my hand, and usually they are the anode side of your capacitor is tapered. So this taper will be on a different side than this black part of a capacitor. So let's do that. I will go back again to grid select and select a grid of 0.5 millimeter. So let's calculate the positions of these coordinates. I have 19 by 19 millimeters, so it's 8.5 by 8.5. So if this is center, 8.5 is somewhere here. So I read my coordinates down here, and then I move my cursor. 8.5 and 8.5. No, this 19. It's a mistake. It's 9.5 by 9.5. So it's over here. I will press enter, and I will go on the other side. If I went on the other side all the way through, it's 9.5, but I will go 2 millimeters back. So 1, 2, 3, 4 parts of a grid. I will go 1, 2, 3, 4 down, and 1, 2, 3, 4 left. Okay, that's it. And I will go from that part. I will go over here, and then I will double click to stop my line drawing. And the same thing I will do over here. Okay, double click. I will go over here, press enter, go all the way to 8.5 and 9.5, press enter and extend all the way to 9.5 here and go back 4, 1, 2, 3, 4, up 1, 2, 3, oops, 1, 2, 3, 4, oops. I need to delete this one, so I need to press enter here again. 1, 2, 3, 4, 1, 2, 3, 4 here, and I will go up. I'll double click it, and this is our capacitor. I will move this over here. I will make this invisible on the board, and that's it. There's not much to it. If you want, you can fill this part. Probably you're asking, why did I draw over this copper parts? And you are right. You are right to ask so, because when you send this to your PCB manufacturer, silk screen, these blue parts will not go over copper exposed parts, and we can repair this part here to look better. I will reduce it here, reduce grid, and then I will do it like this. Well, this is time consuming, and if somebody knows a better way how to do it, put it in a comment. And okay, this is it. I will move this over here. I will check the name of components. So reference is C. 3D settings. I will choose my 3D settings maybe in the last part of this tutorial. So I will save footprint and whole library as this. Close footprint editor. I will return to Kicad, and I will try to find this footprint. Here it is. I'll double click on it, and so I have my footprint for my capacitor, and then I need footprint for this one. As I made this component, there's no footprint for it, so I will go straight away to making a footprint. I will use devices. Nope, I will use another one. I will use local library where I put my local components, and I'll make a new one. I will put the name WireCon, and I'll just edit it as this. I'll put this here and this here. So I'll make a new pet. I will put it everywhere, anywhere I can. I will edit it. So position, let's say for the timing I'll put this at 0. This will be also at 0, and we need to have beefy wire. Let's say at least 2mm wire. So let's make this 4mm. And hole, let's make 2mm hole. So this is drill hole in a PCB, and this is, and let's make this rectangular. Nope. Yeah, rectangular, and I will make 4 by 4mm just to be bigger. Yeah, okay. This is good enough. This is 2mm. Let's put 2.5mm just to be on the safe side. 2.5, and I will put this 4.5 by 4.5, and this is okay. And now, as this will be surface mounted components and my wires will be coming from top, I will push a wire through a hole somewhere here in a PCB, and then bring it up from the bottom and solder it, and that way there'll be some strain leaf on my solder joint here. So I will put a new pad here, but I will edit it, and then I will change this pad type to just non-plate NPTH. That means non-plated through hole mechanical. So this will be just a hole in the board, and position will be, let's say, I will keep it 8mm away from my original hole, and size will be circular also, and size of a drill will be 3.5 millimeters by 5, something like this. Let's put 4 to be on a safe side, so you can put, you know, any, because I will be drilling myself, so that doesn't matter much. Okay, this is our component. Let's move the coordinate system over to the center by hand. This is good enough for me, and I will place it in a, let's select grid of 1mm, and I will encircle it in a nice little square, and I'll double click it. I will move this over here. Let's reduce grid and just put it 0.5 millimeter down, and reference will be P. Yeah, okay. Wire connection will move it here, and also I will make this invisible like everything else I did, so I can save it. Okay, I will close it. I will edit it here. I will assign footprint in my local library, and there should be, yeah, here it is, wire connection. Double click on it, and that's it. Okay, so I think this is I've been talking for more than an hour right now, so this will be part 2 of tutorial. I will just show you how to so I've shown you one way of choosing your footprints for your components. The other way is to go here, CVPCB, and each time you start it, first time you start it, it'll take a long time until it loads all of the components, so we need to wait. I might edit this out. Okay, I have my project loaded from here in CVPCB. So I need to find, you can see I have 3 unpopulated footprints for my project, and I know already that they are placed in the local library and they are named WireCon. So I will click on first one, and then I will double click. This is a bit tricky. First time I didn't, I couldn't find how to choose it. And I will double click on wire cone, and I will do it just 3 times, because every time you click, Kicad just moves on next unpopulated component. Okay, and I will save it. When you exit from Kicad and go back to your schematic, if you check your parts for wire connectors, you can see they are all populated. Okay, this concludes this second part. I thought I could fit like making a PCB also in 1 hour, but I do it very slowly, just for beginners. Just for beginners, if you haven't been using this Kicad or any PCB program before, I try to do it slower. So this is part 2. In next part we will be making our PCB, and part number 4 I will try to edge it. Thank you guys for watching. If you like this video, just press thumbs up. See you next time.